Okay, now let's review theorems on chords, arcs, central angles, and inscribed angles. So, balikan lang natin ulit yung mga theorems on chords, arcs, central angles, and inscribed angles. So, number 1, in a circle or incongruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So, ito na rin yung diniscuss natin before. So, here in circle E, we have central angle SE. And this is congruent to central angle NEO because both of them measures 50 degrees. Since the two central angles are congruent, the minor arcs they intercept are also congruent. So we can say that arc ST is congruent to arc ON. If circle E congruent to circle I and angle SET congruent to angle NEO congruent to angle BIG, then their corresponding intercepted arcs are also congruent. So we can say that arc ST is congruent to arc NO congruent to arc BG. So that is in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So that's theorem number 1. Next, number 2. In a circle or incongruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we have circle T. Line segment PA congruent to line segment CH. Since the two chords are congruent, then we can say that their corresponding arc are also congruent. So we have arc BA congruent to arc CH. Circle T is congruent to circle N, and BA is congruent to CH congruent to OE. Then arc BA is congruent to arc CH congruent also to arc OE. Okay, that's the theorem for chords and arc. Next, number 3. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. So in the illustration, ES is the diameter. It intersect chord GN and arc GN. So at the point of intersection of diameter SE and chord GN, it forms perpendicular line. So if it forms perpendicular line, we can say that line segment GI is congruent to line segment IN. And arc GE is congruent to arc EN since the diameter bisects the chord, meaning it forms perpendicular line. Next. What about the theorems on inscribed angles? Let us recall also this. We have 4. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So na illustrate na to dun sa previous module, that the measure of the inscribed angle is equal to 1/2 of the measure of its intercepted arc. That's why the figure at the right here, we have angle ACT as our inscribed angle, and its intercepted arc is arc AT. So we can say that the measure if the measure of arc AT is 120 degrees, so this arc AT is 120, we can find the measure of our angle ACT, the inscribed angle, by getting the half of arc AT using this theorem. So measure of angle ACT, inscribed angle, is equal to 1/2 of the measure of its intercepted arc AT, which is 120. Measure of angle ACT now is equal to 60 degrees. Since this is 120, the arc, the inscribed angle now that intercepted arc is 60 degrees. Next, let's have another example. The inscribed angle here is angle PQR, and this angle is 50 degrees. So this angle measures 50 degrees. The question is, what is the measure of arc PR? So you need to find the measure of its intercepted arc. So using the relationship, angle PQR is equal to 1/2 of its intercepted arc PR. By substitution, measure of angle PR is 50 is equal to 1/2 of the measure of arc PR. So multiply both sides by 2 to find the measure of PR. So this multiplication property of equality. Arc PR is equal to 100 degrees. Next, if the measure of arc AT, so this is the intercepted arc of angle ACT. If arc AT is 130, then ACT is 1/2 of measure of arc AT. That's why we have here, getting the half of the intercepted arc AT, 130, it gives us 65 degrees as the measure of the inscribed angle ACT. Next, theorem number 2. If two inscribed angles of a circle or congruent circles intercept congruent or same arc, so isang arc lang in-intercept ng inscribed angles, then the angles are congruent. So like as what we have here in the illustration, angle PIO, inscribed angle, another inscribed angle is angle PLO. Both of these inscribed angles intercept the arc PO. So it means that the two inscribed angles have equal measure since they intercept same arc based on theorem number 2. So if arc PO is 98, then the measure of angle PIO and the measure of angle PLO is just 1/2 of its intercepted arc, which is 98, and its half is 49. So angle PIO is 49, angle PLO is also 49 degrees. Next, if an inscribed angle of a circle intercepts a semicircle, then the angle is right. So this one, we have angle NTE, that is an inscribed angle. And based on the endpoint of the two sides of this inscribed angle, we have point N and then point E. It inscribed a semicircle. So this is a semicircle that inscribed or intercepted by angle NTE. So ayan. If arc NSE is a semicircle, then angle NTE is a right angle. So it measures 90 degrees. If and only if that inscribed angle inscribe a semicircle, then the angle or the inscribed angle is a right angle or measures 90 degrees. So in another figure here, what is the measure of angle X here? Since as we can see, angle X, an inscribed angle, intercepts semicircle. Therefore, angle X is 90 degrees. Okay. Last theorem for inscribed angles. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So we have here four-sided polygon, that's a quadrilateral, which is inside a circle. So that is theorem number 4. So if that quadrilateral is inscribed in a circle, then the opposite angles of this quadrilateral are supplementary. So ibig sabihin, if we add angle D plus angle E, this is equal to 180 degrees. Then angle R plus angle A, that is also equal to 180 degrees. So through the use of this relationship, opposite angles are supplementary. So we can find the measure of the unknown angle of a quadrilateral inscribed in a circle. The example is, we have here quadrilateral DEFG inscribed in circle. So if angle EDG, this one, angle D, measures 85 degrees, what is the measure of angle EFG? So for our solution, we just substitute the measure of EDG, 85, plus the measure of the unknown angle EFG is equal to 180 degrees. because angle EDG and angle EFG are opposite angles of quadrilateral inscribed in a circle. So the sum of these two is 180. Then by simplifying using subtraction property of equality, the measure of angle EFG is equal to 180 degrees minus 85. Therefore, angle EFG is equal to 95 degrees. So 85, if this is 95, if we add, it gives us 180. So therefore, they are really supplementary. Additional example. So if arc SR, this one is 60 degrees, and angle RST is 40. What is the measure of arc ST? The major arc. So you're going to find the measure of the major arc. If this one is 60. So we apply theorem number 1. The measure of the inscribed angle RST is 1/2 of the measure of its intercepted arc TR. So we have here angle RST is 40 equals the measure of 1/2 of the measure of arc TR, the unknown arc. So using multiplication property, in order to find the measure of arc TR, we obtain arc TR is 80 degrees. Since arc SR is 60 already given, and we found that arc TR is 80. Okay, we can now use the arc addition postulate. These two are now given. 60 plus 80, so we can find the remaining arc by using arc addition postulate, that arc TR plus arc SR plus arc ST is equal to 360. So in this case, the unknown is arc ST. By substitution, arc TR is 80, arc SR is 60, then the unknown arc is arc ST. This is equal to 360 degrees, one complete rotation. So the sum of these two is 140 plus arc ST is equal to 360, and then apply subtraction property of equality. ST is equal to 360 minus 140, then we can find that the measure of arc ST is equal to 220 degrees. Another one. So if the measure of angle G and M, so this one, angle N, is equal to 108 degrees, and then arc NM, this arc is 44 degrees, find the measure of arc NG. So we need to find this arc NG. Since our angle N is already given, we can find the measure of arc GKM, wherein arc GKM is the intercepted arc of angle G and M. So application of the theorem, inscribed angle is equal to 1/2 of its intercepted arc. We have angle G and M is equal to 1/2 of the measure of arc GKM. Substitute the measure of G and M, 108 is equal to 1/2 of the measure of arc GKM, the unknown. So to find the measure of arc GKM, multiply both sides by 2. Meaning we have 2 times 108 is equal to 216, and that is a measure of the intercepted arc GKM. Since GKM is 216 degrees and given ang measure ng arc NM, which is 44, we can now find the measure of arc GN by using arc addition postulate. That arc GKM plus arc NM plus arc NG is equal to 360 degrees. So substitute 216 plus 44 plus the unknown arc NG is equal to 360, because those three arcs makes a complete rotation. That is one circle. That's why this is equal to 360. So 216 plus 44 is 260 plus arc NG is equal to 360 degrees. Subtraction property of equality, we have NG is equal to 360 degrees minus 260 degrees. Therefore, arc NG is equal to 100 degrees. Okay. So that's all for theorems on chords, arcs, central angles, and inscribed angles.